Let's review the product rule, but still using that theorem number 12 that stated derivative of a to the x power is natural log of a times a to the x. So we are going to use this theorem. Okay, but we will combine this with the product rule, the review material. So let's take a look. Differentiate. G of x is x to the fifth power times 3.5 raised to the x power. So I'll go ahead and identify that my first piece is x to the fifth and f prime is 5x to the fourth. I am setting up my product rule here, okay? G, the second piece of the multiplication, is 3.5 raised to the x power. Well, then what is G prime? Well, G prime is, you write that down first, 3.5 to the x power. That stays the same. But I need to now multiply that by natural log of 3.5. Oh, I'm going to have to move this one a little bit to the side. Okay, so I got all my pieces ready for product rule. Let's do the product rule then. G prime of x is going to be, and I'm sorry that I'm using the name G, which represent the second piece in my product rule. So I hate it. I should have probably changed the name of this function to like h of x, but you see what I mean by G and all that, right? So I need to do first times the derivative of the second. First is x to the fifth power. So x to the fifth power times the derivative of the second, that long expression, which is natural log of 3.5 times 3.5 to the x power plus second times the derivative of the first. I need to multiply those two that I circled. So that will be 3.5 to the x power times 5x to the fourth power. Okay, let me zoom out for you. And now let's focus on simplifying this. I want you to look and see if we can factor out a greatest common factor. They have some things in common, don't you think? All right, give me 1 second. How long this parenthesis was bothering me, so I'm going to go ahead and rewrite this. 5x to the fourth power. Okay, let me use my colors and highlight some of the like terms that I noticed, okay? I see that both terms have 3.5 to the x power. So I'm going to factor that out and factor 3.5 to the x power out from the second term. Now, what else do they have in common? Not exactly the same, but this term has x to the fifth power and this term has x to the fourth power, right? So I can factor out x to the fourth power, and the first one will still have one of them left. So here we go, G prime of x in a factored out form. I will have x to the fourth power outside times 3.5 raised to the x power. And that's getting multiplied by x times natural log of 3.5 plus 5. Isn't that right? So I am done with this problem over here. I guess, I don't know, the line above looks pretty good to me too, but I don't know if I really needed to factor this out, but I don't know, it just kind of felt like it. They are the same thing though. All right, how about one more on product rule? Let's do another problem on product rule. Eee, look at how yucky the second term is this time. All right, let's see what we can do over here, okay? So first of all, the first piece is, I'll call it x to the seventh power. Then f prime is 7x to the sixth power. G is equal to 5 raised to the negative 2x to the third power. Oh, goodness. So let's take the derivative of that. Okay, this may take some time. Let's do this one a little bit slow. If you take the derivative of this, you will have to multiply this by natural log of 5, the base, and that term, 5 to the negative 2x to the third power. But not only that, we now need to multiply this by the derivative of the exponent. Okay, that's where I'm out of room, so let me just write it. Negative 6x squared. And if you're wondering where did you get that from, this is the derivative of negative 2x to the third power. Okay, there's nothing I can do here. This is just a three-term, little ugly three-term getting multiplied. But I'll just write them next to each other, clearly separated by these parentheses. But, well, got all my pieces ready. Let's do the product rule. It's going to be a long line. All right, so the derivative is going to be first times the derivative of the second. So I have to put all those four things next to each other. So first, x to the 7th times derivative of the second is natural log of 5 times 5 raised to the negative 2x to the third power times negative 6x squared plus, okay, second times the derivative of the first. So I'll go ahead and multiply those two. There's nothing much I can do. I can just write them next to each other. 5 raised to the negative 2x to the third power times 7x to the 6th power. All right, let's see if we can simplify anything over here. Before I can factor out, I see the first term, I can multiply x to the 7th power by that term right there. Those two are polynomials. So I can say negative 6 times x to the 9th power. All right, 7 plus 2 give me 9. And I can write down natural log of 5. Just copying down the rest of it, really. 5 times, or 5 to the negative 2x to the third power. Close parenthesis. And then the rest of it, the second term that was in the second line, which is 5 to the negative 2x to the third power times 7x to the 6th power. I guess I can stop here, but I do see common factors, so I do want to pull some common factors out. What are the common factors? This ugly term, almost looked like a typo, Jesus. And I can factor out x to the 6th from these two. So I will say my final answer is x to the 6th power times 5 raised to the negative 2x to the third. I will close the parenthesis and open a big parenthesis. And what's left inside? Well, inside I will have negative 6 x to the third power times natural log of 5 plus almost everything got pulled out in the second term except for 7. And that is how I would just write my final answer for this problem. Oh, this is just delightful, don't you think? It was an interesting problem, but these two I consider to be the more complicated example. I don't know if I want to put something like this on your second test. Probably gonna give you a word problem. I'd rather, because these ones, if you want to check it on your, like if you're taking this, if you're doing this and just want to check this online, if you're doing your homework, I guess you guys can find the answers really quick on these online calculators. That's why on the test you will not really see something like this. I would rather ask you for example 3, like a nice word problem. But that is enough of those two examples. I will come back and record example number 3, the Nilam population problem, in just a second.